All right, welcome back. Honors Algebra, Hononegah Honors Algebra 2. This is actually the Law of Sines, Day 2. Let's talk a little bit for geometry, okay? And this isn't on your note sheet, but let's just talk. So just watch this for a second. Remember back when you did geometry theorems and congruent triangles and angle side angle and angle angle side. Those are actually law of sines. And then side side side, side angle side, those are law of cosines. And we'll get to law of cosines tomorrow. But remember, there was one that never worked. It was called side-side angle or angle side-side. We don't use that abbreviation because ultimately it spells a bad word. But that one doesn't work. And they really don't explain why it doesn't work very well. But here's why. And I'm going to show this to you on the next picture. And again, this is not on our note sheet. But side-side angle doesn't work because it actually creates two different triangles. That is why they're not necessarily congruent. And I'm going to draw this picture one at a time. So if I gave you a triangle that has a 30-degree angle, this side's 11, and this side is 5. I can make another triangle with the exact same situation. This side's 11, this side's 30, and this side is 5. So that, and notice when you look at those two pictures, they are not congruent. They are not the same. So I refer to that as a hinge situation. If you are ever given an acute angle, and I'll get to this maybe on the next slide, but an acute angle, and the side opposite is smaller than the adjacent side, that is when this situation occurs. So here's what could happen. This is now in your notes. If you have two sides in a non-included angle, SSA, and the angle is smaller than the side, and the opposite angle is smaller than the side adjacent to the angle, assume that there can be two solutions. So if you have an acute angle and the side opposite is smaller than the side adjacent, so A is less than B, and you have an acute angle, A. If you have this situation, you could have no solution. Now, how are you going to know if there's no solution? Your calculator is going to give you an error message. That one's going to be given to you. So you start doing the law of sines, and all of a sudden you get an error message. Then you need to look back and say, wait a minute, that's not possible. Next, you could have one solution. This doesn't really happen very often, but if you happen to get this angle to be 90 degrees, there technically is only one solution. Again, that will not occur on your test or on your quiz, but technically speaking, it could happen. And here's the big one. Here's the one that is honors level. Now I'm given angle A, and it's an acute angle, and the side A is smaller than B. That is two solutions, and we'll talk about that when I actually get into some numbers on how we're going to handle it if there are two solutions. So here we go. Let's actually try a picture. This looks very similar to the first day. You are given a triangle, A, B, C. So just make up a generic ABC, of which angle A is 70, side A is 2, so I'm not drawing to scale here, and side B is 12. So that is the scenario we talked about. Angle A is an acute angle. The side opposite is smaller than that of the adjacent, so this could be a two triangle situation. Well, let's actually try to, so the sine of 70 over 2, this is the law of sines, would equal the sine of angle B over 12. Cross multiply just like you did yesterday. Divide by 2. And now I'm going to pull out my calculator. 12 times the sine of 70 divided by 2 is ended up being 5.638. Inverse sine. Uh-oh. I get an error, which means there is no solution. You cannot draw this situation correctly. Okay? If you had a 70-degree angle and the side opposite is only 2, this side cannot be 12 and make a triangle. Okay? The side 2 is not long enough to actually make an angle measure. So again, you would write no solution. All right, now comes for the big one. This is the one, if we have an assessment at the end of this section, this is the one that is missed the most. So here we go. I'm going to draw a picture. A, B, C. I'm given A as being 25. Side A is 5, and side B is 10. So this fits my scenario. I have an acute angle. The side opposite is smaller than that of the adjacent. This could be two triangles. Here's how you know. go ahead and start doing the law of sines, just like you always would. So the sine of 25 over 5 and the sine of b over 10. Cross multiply. Divide. So now on my calculator, I'm going to do 10 times the sine of 25 divided by 5. Then I'm going to do second sine of that answer, and I'm going to get b to be 57.7 degrees. All right. Since this worked, since you got an angle for b, that means there's an entirely second triangle, and I'm going to draw a little better picture, that goes this direction. Angle B, 10, 5, 25. And again, you don't have to draw the picture correctly, but angle B in this question is 57.7. Angle B in the second triangle is always the supplement. For those of you who don't remember, supplement is adding up to 180. So if angle B is 57.7, then angle B in the second one is 122.3 because it is the supplement to the angle B. So these in the first triangle is the supplement to the second triangle. Now they are two completely separate questions. Okay, you are literally going to scroll down here, and I'm going to do everything for this picture over here using angle B as being 57.7, and I'm going to do everything over here using angle B as being 122.3. So if I'm going to try to find angle C over here and side C over here, and I'm going to try to find angle C and side C over here. So again, one picture, the other picture. We'll call this one picture 1, picture 2. All right, so triangle 1. 57.7 for B, 25 for A. That means angle C has to be 97.3, subtracting from 180. And again, kind of running out of space here. So now I'm going to squeeze this in. Sine of 97.3 over C would equal the sine of 25 over 5. Cross multiply and solve. Sorry about the small space, but that would be 11.74. Over here, I got a little more space now. Sine of, or excuse me, first I have to find angle C. So B is 122.3. A is 25. Add those together, subtract from 180. That makes C 32.7 degrees. And now the sine of 32.7 over C would equal the sine of 25 over 5. Cross multiply and solve. C is 6.39. I'm going to run through this scenario one more time because I know this was a little bit confusing and I don't think I drew the best picture here. But if you have an acute angle, side opposite is smaller than that of the adjacent side, do the law of sines. If you get an answer, so if you get an answer, it's not an error message, or 90 degrees, okay, then you just do one picture. If you get an answer, one triangle is the answer, and the second triangle is the supplement to that. Hopefully you were able to understand that. I might have to do another example to help some people out, but your homework assignment is the day 2 worksheet. Again, some of them will have one answer. Some of them will have 2 answers. Do not, okay, so just make sure you understand what you are given, and what you're looking for is an acute angle and the side opposite being smaller than the side adjacent. That is the only time you can end up getting 2 solutions. Good luck. If you do have any questions, make sure you talk to myself or Ms. Kinsel. And again, be safe.